Okay, exercise 1.3. We'll start off with question 1. Prove that root 5 is irrational. So, how do we do that? The solution is, let us assume to the contrary that root 5 is rational. So, we can find coprime integers a and b such that b is not equal to 0, such that root 5 is equal to a by b. Now we cross multiply. Root 5 into b is equal to a, which implies if you are squaring on both sides, we get 5b square is equal to a square. Therefore, 5 divides a square, and also we have 5 divides a. So we can write a as a multiple of 5 for some integer c. So we write a is equal to 5c. So now squaring on both sides, in the place of a we'll write it as root 5b. So substituting a, we get root 5b is equal to 5c. Squaring on both sides, we get root 5b whole square is equal to 25c square, or 5b square is equal to 25c square, which implies b square is equal to 5c square. So what do we get from this? We get 5 divides b square, and so 5 divides b. So a and b have at least 5 as a common factor. So there is a common factor, so these cannot be coprime numbers. A and b cannot be coprime. So this contradicts the fact that a and b are coprime or have no common factors other than 1. This contradicts the fact that this contradiction has arisen because of our incorrect assumption that root 5 is a rational number. Therefore, we can conclude that root 5 is not rational, it is an irrational number. So question 2. Prove that 3 plus 2 root 5 is irrational. So in this problem, if you prove root 5 is irrational, then we can tell that 3 plus any rational number is again an irrational number. So again, in the same way as the first one, we proceed. So let us assume to the contrary that three plus 2 root 5 is rational. That is, we can find coprime integers a and b such that b is not equal to 0, such that 3 plus 2 root 5 is equal to a by b, where a and b are coprime. So we can write this as 3 plus 2 root 5 is equal to a by b, or a by b minus 3 is equal to 2 root 5. Or if you take LCM, you will get a minus 3b is equal 3b by b is equal to 2 root 5. So we have a minus 3b by b is equal to root 5, which implies a by 2b by minus 3 by 2 is equal to root 5. Since a and b are integers, we have a by 2b minus 3 by 2 is rational, and so root 5 is rational. But this contradicts the fact that root 5 is irrational. This contradicts the fact that root 5 is irrational. This contradiction has arisen because of our incorrect assumption. This contradiction has arisen because of our incorrect assumption that 3 plus 2 root 5 is rational. Three plus 2 root 5 is rational. So we conclude that 3 plus 2 root 5 is irrational. Since root 5 is irrational, anything added or multiplied to root 5 is again an irrational number. So therefore we conclude that 3 plus 2 root 5 is irrational. Now going to the next problem. Question 3. Prove that the following are irrational. So we have here 3. The first one is 1 by root 2, second 7 root 5 and 6 plus root 2. So one is added, one is multiplied and one is division. So now we have to show that these three are irrational numbers. So irrational number, whether multiplied, added or divided, will always be an irrational number. So we'll again take a contrary statement and then prove it is false, and then the given statement is true. Given whether it is irrational or rational, it is true. So let us assume to the contrary that 1 by root 2 is rational. We always assume to the contrary whatever is given to us. It's given as irrational, so we assume that it is rational. So whenever it is a rational number, we can express any rational number in the form of p by q, that is, or a by b, where a and b are integers. So we can find coprime integers a and b not equal to 0 such that 1 by root 2 is equal to a by b, which implies that root 2 is equal to b by a. We are cross multiplying. Since a and b are integers, a by b is an rational number. A by b is a rational number. And so what happens here? Root 2 is also a rational number. But this contradicts the fact that root 2 is rational. But this contradicts the fact that root 2 is irrational. So we conclude that root 2 is irrational. Therefore 1 by root 2 is also irrational. Okay. Second one is 7 root 5. Let us assume to the contrary that 7 root 5 is rational. So you are always taking a contrary statement or a contradictory statement, that whenever a number multiplied with a irrational number is rational, actually we have to prove that it is irrational. So we can find co-prime integers a and b such that b is not equal to 0. Then we can write 7 root 5 is equal to a by b. Therefore root 5, if you cross multiply, you will get it as root 5 is equal to a by 7b. Since a and b are integers, a by 7b is rational. And so root 5 is rational. But this contradicts the fact that root 5 is irrational. But this contradicts the fact that root 5 is irrational. So we can conclude that anything multiplied with root 5 is again an irrational number. So we get 7 root 5 is irrational. We can conclude that 7 root 5 is irrational. Then last we have 6 plus root 2. We have to prove that it's an irrational number. Yeah, addition of an irrational number with a rational number is always irrational. We'll prove that. So we are again assuming that to the contrary, that root 2 is rational. So then 6 plus root 2 is rational. So we can find co-prime integers a and b. So we can find co-prime integers a and b. B not equal to 0, such that 6 plus root 2 is equal to a by b. Or you can write this as 6 minus a by b is equal to minus root 2. Now since a and b are integers, we get or you can also write root 2 is equal to a by b minus 6. Since a and b are integers, we get a by b is rational. And so a by b minus 6 is also rational. So root 2 is rational. But what is happening here is a contradiction to the fact that root 2 is irrational. So we conclude that 6 plus root 2 is irrational. So we conclude that 6 plus root 2 is irrational. So addition to a irrational number is irrational, multiplication to a irrational is irrational, division to a irrational is an irrational number.